In lesson 3, we're going to look at triangles again, and we're going to do a little bit of trigonometry. Now, the first thing we're going to be able to do is recognize and label the parts of a right triangle. We have already heard of the third one there, the hypotenuse, but we're going to also figure out how to label the opposite and the adjacent sides as well. We're also going to use the sine ratio to find unknown sides of a right triangle. And we're going to use the sine ratio to find the unknown interior angles of a right triangle. Now, it would be good to get the acronym in your head, SOHCAHTOA. Some people pronounce it SOHCAHTOA. We'll pronounce it SOHCAHTOA. And today we're going to focus on the first third of that, which is the SOH, so. And we'll talk about why in a moment. The ka and the toa will come along later in other lessons. So what are we talking about here? That's talking about the sine ratio. That's what S is standing for, is sine. And so what just is that? Well, we can use the opposite and hypotenuse sides of a triangle to figure out either an angle or a side length. Now, the sine ratio, as this says, the sine ratio can be used to calculate an unknown side length or an angle as long as we have a right triangle. Again, it has to be a right triangle. But which side is the opposite side, which side's the hypotenuse, which side's the adjacent? So here we have a triangle, and let's label this triangle A, B, C. From other lessons and other math courses, you already know that this side has to be the hypotenuse. It's the longest one, and it's the one that's across from the 90-degree angle. So I'm going to label this as an H for hypotenuse. Now, if this is the hypotenuse, which side is opposite and which side is adjacent? Well, it kind of depends on which angle we're referring to. So let's look at it from perspective of angle A. So we could say sine A equals opposite divided by hypotenuse. And by definition, sine of some angle is equal to opposite over hypotenuse. It will always be opposite over hypotenuse. But which side is opposite? We already know which side is hypotenuse. Which side is opposite? Well, from angle A's perspective, imagine you are standing at angle A, and you look out over this triangle, and this triangle's, let's say, inscribed on the floor somehow. This side right over here would be opposite of angle A. Because it's on the other side of the triangle, the exact opposite side of the triangle. So this is the opposite side in this case, which means there's only one side left. This would be the adjacent side. Adjacent just means adjoining or next to. So if we're talking about angle A, this side is a part of angle A, right? Angle A includes these two sides, so this would be adjacent. Now suppose for a second we want to think about sine of a different angle. So sine B. Sine B is actually also opposite over hypotenuse. By definition, sine of an angle is always opposite over hypotenuse. But we're talking about angle B now. So you have to imagine that you're standing up here at angle B and you look out over the triangle. Now this is the opposite side from angle B's perspective, and this would be the adjacent side from angle B's perspective. And the hypotenuse will always remain the same. It's always the longest side. So you have to really pay attention to which angle we're talking about before you can figure out which side is opposite and which side is adjacent. And just as another note, to solve any of these types of problems, make sure that your calculator is set to degree mode. Sometimes that will show up somewhere in there as just a DEG or something like that. If you're not sure, just ask your teacher. In this example, we're going to use the sine ratio to calculate the value of side x. We already know that side x is the hypotenuse, right? It's the longest side. So if this is the hypotenuse, what side is this? Is this adjacent or opposite? Well, if we look from angle C, this side over here would be opposite since it's directly across from angle C, across the triangle. But if we look from angle A, 12 would be opposite directly across. Now remember that we said the sine of some angle, I'm going to leave this spot blank for a second, the sine of some angle is always equal to the opposite divided by the hypotenuse. That's just by definition. Now to shorten this down, we often just write O over H, opposite over hypotenuse. So the sine of some angle is equal to opposite over hypotenuse. But which angle are we going to use? Well, we don't know the value of angle C. I mean, we could calculate it because we know that B is 90 degrees and we know that A is 43, but why would we go to that trouble when we already know angle A? We know angle A is 43 degrees. So sine of angle A, this is the one we're going to use, is opposite over hypotenuse. So sine of angle A is equal to opposite over hypotenuse. Now let's plug in the things that we know. We know that angle A is 43 degrees. So sine of 43 degrees is equal to opposite. What's the opposite of the 43 degree angle? This 12 is. So is equal to opposite over hypotenuse. We don't know what hypotenuse is. In this case, it's x. It's what we're trying to find. So we can write x. Now, what is this sine 43? What is that talking about? Well, if you pull up your calculator, you'll be able to see 3 buttons on your calculator. There's usually students call it sin, cos, and tan. It stands for sine, cosine, and tangent. This is the one that we're going to be using today, the sine button. Okay, so what is sine of 43 degrees? Well, we're making sure we're set to degree mode. And we can hit, on this calculator, you have to type in the angle first and then press sine. Sine of 43 degrees is this weird long decimal number. Now, you will be accurate enough as long as you take the first 4 digits and make sure this one is rounded. So this says 0.681998, etc., etc. We're going to use 0.6820 because this 9 will round this 9 up to the next digit, which would be a 0, and that 1 carries over here. So 0.6820. So sine 43 is just 0.6820 equals 12 divided by x. Now using our algebra, we can multiply both sides by x times x times x. That way these x's cancel. And now we have x times 0.6820 equals 12. X times 0.6820 equals 12. And we want to solve for x, so we're going to divide both sides by 0.6820. That way these will cancel. Divide by 0.6820. And 12 divided by 0.6820. So 12 divided by 0.6820, we get 17.6 when we round that. Okay, so that would be 17.6. And that is x. In this case, x is the length of our hypotenuse. The number makes sense simply because it's longer than the 12, so that makes logical sense that it would be longer than the 12. It's not shorter because it's the hypotenuse value. Find the value of x once again. So in this case, you can see our x is right here, and we do know our hypotenuse already. Our hypotenuse is right here. So this is hypotenuse side. Now again, we know this angle A, we don't know angle C, so let's think of it from the perspective of angle A. If we are talking about from angle A being the important angle, then this side would be opposite. So once again, we know sine of our angle is equal to opposite over hypotenuse. That's just by definition, that's what sine of an angle means. It's the ratio of opposite divided by hypotenuse. In this case, our angle is 30 degrees, so we know sine of 30 degrees is equal to opposite, in this case, opposite is x, divided by hypotenuse. Our hypotenuse has a value of 2. And now let's figure out what is sine of 30 degrees. So we're going to bring our calculator up again, and I'm going to type in 30 sine, and I see it's 0.5. Don't even have to round at all. So sine of 30 degrees is just 0.5. 0.5 equals x divided by 2. Now I'm going to multiply both sides by 2. To get rid of the 2 from this side, the opposite of dividing by 2 is multiplying by 2. That's why we do it. Whatever you do to one side, got to do to the other. We're left with an x on this side, and 2 times 0.5 is just 1. So in this case, x happens to be equal to 1. So the side length right here is 1 long, if this is a 30-degree angle and our hypotenuse is 2. Find the value of angle A. Now here's our angle A right here, and we need to figure out what is that value, what is the value of this angle. Well, let's start by writing down our equation. We know that sine of an angle, and we're going to be working with angle A probably, so sine of angle A is equal to opposite over hypotenuse. Now in the previous two examples, we knew what angle A was, so we would plug that number into here, and then we punch that in the calculator, we get some decimal number, and we'd solve for either opposite or hypotenuse. In this case, according to angle A, from the perspective of angle A, if you were standing here, opposite is 18, and of course hypotenuse has to be 23 because it's the longest one. So sine of our angle, and we don't know what this is yet, is equal to opposite is 18, divided by hypotenuse, which is 23. Okay, so we know that sine of our angle is equal to what is 18 divided by 23? That's a good question. So 18 divided by 23 is equal to 0.78260, etc., 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 etc. Again, we're going to use 4 decimal places here, and since right after the 6 is a 0, we can just leave that as a 6. So 0.7826. 0.7826. That's 18 divided by 23. We're almost there. In the past, we were using the sine button on an angle, and we were getting some decimal number, but now we want to figure out what that angle is. So we could start randomly guessing angles. Sine of 10 degrees, is it that? Sine of 20 degrees, is it that? Well, that would take way too long. Instead, what we're going to do is the opposite operation of a sine, and that's taking sine -1 of an angle. Now on your calculator might have a second function button, and when you press it, you can see we have this sine to the power of -1. That means take the opposite of the sine of an angle. So sine -1, when we press that button on this value, we end up with a 51.5. And we'll talk about what that means in a second. But for right now, so far all we know that sine of some angle is equal to 0.7826, but we just want to know what is A. So in order to bring the sine over to this side, we're going to go sine -1 of 0.7826. What is sine -1 of this decimal number? That is going to give us our angle. So we'll bring up the calculator, and we'll go 0.7826, and we'll hit our sine -1 button, and it will tell us 51.4992. We're going to round this because it's our final answer to 51.5 degrees. So this is our answer, this is our degree, 51.5 degrees. I'll write that down. A must be 51.5 degrees. Now we can work backwards and see what is sine of 51.5 degrees. So we pull out the calculator. Let's say we had 51.5 degrees, and we hit sine of that. We should end up with this decimal number, or very close, 0.7826. 0.7826. So in summary, For any right angle triangle, for a given angle, so we have to remember, take the perspective of this angle or this angle. If we're talking about this angle, the sides can be labeled as opposite, adjacent, and hypotenuse. Opposite is always across from the angle we're thinking about. Adjacent is always part of the angle we're thinking about. And hypotenuse is always across from the 90-degree angle. This one's always the longest side, just like you've learned before. The sine ratio is sine of the angle is equal to the opposite side divided by the hypotenuse side. We can use the sine ratio to find missing angles or missing side lengths in a right triangle. We use the sine button on our calculator to find the ratio when we're solving for a side, and we use the sine -1 button to find the angle when we're solving for an angle.